Welcome everyone to the PhD defense of Dylan Cawthorne. My name is Ulrik Schultz. I'm an associate professor here in the Drone Center at the University of Southern Denmark. And today, Dylan is going to be defending his PhD thesis, value-sensitive design of unmanned aerial systems. And I will be chairing the defense, which means that I'm just here to keep everyone in order and making sure that things proceed appropriately, that Dylan doesn't speak too long and all those things. I would, of course, here we're very happy to be welcoming everyone here in the audience, and in particular also welcome to the judging committee. So the judging committee are the members of the judging committee are Associate Professor Anders Stengård Sørensen, here from the University of Southern Denmark. Welcome, Anders.
Thank you.
And as external members of the Relation Committee, we have Professor Sarah Spiekermann-Hoff from Vienna University of Economics and Business in Austria. Welcome, Sarah. And we also have Professor Ibo van der Pol from the Technical University of Delft in the Netherlands. Welcome, Ivo. And of course, good. And of course, also welcome to the supervisors. So we have Professor Alf Ring here from University of Southern Denmark, and we have his two co-supervisors, Associate Professor Marianne Harbo Frederiksen, and here also from SDU, and then Douglas Kimes from Montana State University. So welcome everyone. The way this defense is going to proceed is as follows. And at this point, I'd like to remind everyone to keep your microphones muted unless you have a good reason to unmute, such as if you're asking a question or well, that's basically it. The way the defense is going to proceed is that Dylan will shortly start to give his presentation, which should last between half an hour and 45 minutes. Then I will allow questions from the audience, a sort of limited number, but some, depending on the timing. After that, we'll have a short break. After this break, we're going to proceed with the questions. So the two members of the two external members of the Relation Committee will have a full hour to ask questions to Dylan, followed by half an hour by the internal chairman of the Relation Committee, Anders, who will have half an hour to ask questions. At that point, the Relation Committee is going to retire to a separate room. So in Zoom, we can sort of move them into a separate place where they can talk to each other and decide on the final verdict for Dylan. And we would expect this might take half an hour, but you know, sometimes it takes longer because there might be lots of things to discuss or whatever. After that, they will come back in the same Zoom session here and will tell us the result of the evaluation. So with that, Dylan, I would like to, sorry, I think Dylan, you would like to have permission to present?
Yes, please.
That would make sense.
Says that it's disabled right now.
Yeah. I'm going to make you a co-host of the meeting for now.
Mm-hmm.
I think that should be an easy way to allow you to present without allowing it in general. Can you confirm that you are able to present now?
I believe so.
Yes, looks
that
good.
Looks promising. Is it in full screen mode or is it in normal mode?
It is in normal mode.
Okay, and now?
Now it looks good. Perfect.
Okay, wonderful. Thank you all for joining. It's great to see all my family and friends here, and good to see Ivo van der Pol and Sarah and Anders again. Yes, so today I'm going to talk to you about value-sensitive design of unmanned aerial systems. A quick overview. My plan is to talk about, just briefly, I want to review the work that went into the thesis itself. Then I want to discuss some conclusions of that work. And then in the end, of course, we have a nice discussion. So first, I wanted to discuss the motivation of this work. So there's a lot of different narratives out there surrounding drones, and some of them is Some of them are very dystopian in nature, I would say. So this is a fiction film called Slaughterbots, which is about some kind of drones coming in and murdering people, attacking them in the head and exploding. But we've also seen some pretty problematic stuff already happening with drones. So there's these risks of statewide surveillance. There's these possibilities of privacy violations, widespread privacy violations. And then even if we think about less dramatic type of risks, then there's of course things like massive job loss due to automation. So what's going to happen when drones and automation replace a lot of the workforce? What's going to happen to normal members of society? So this is sort of the dystopian version narrative around drones. And let's see if this will switch. And then we also have another narrative, which is something about how great drones are. So this is a company called Zipline, and they're saying hashtag drones for good. Look at how great our technology is. We're using it for healthcare. We're helping people. We're saving lives. We're dropping blood samples into remote areas in Africa, for example. So I kind of am interested in these different narratives and exploring this topic to say, okay, us as drone engineers, are we in fact making good drones? Are we making bad drones? Is there such a thing? And if so, how does that play into the design of the technology? Just to establish some context, I'm here at the Drone Center, and we have this mission statement, which is about making drones for the benefit of society. So in order to know how to do this, we need to know, how do we design technology that's going to benefit society? And therefore, we need to think about things like ethics and human values in the process of technology development. Just so we all know what drones and VSD are, here's a very quick introduction. The drones that I focused on in this work are small drones for commercial purposes, so they're usually under 25 kilos. You can see the one on the left is a multi-rotor, so it's sort of a helicopter. It flies vertically like this. The one in the middle is fixed wing, so it's sort of like a miniature airplane and flies forward. And then recently we have this new development, which is some kind of vertical takeoff drone, which can both take off vertically and then fly like an airplane. So in this work, at the beginning, I didn't really know what kind of methodologies were out there to systematically take ethics and human values and then incorporate them into technology design. And after about 6 months, I found this methodology called value-sensitive design, and it's talking about human values in the design of technology. You can see that it consists of 3 main phases: a conceptual phase, which is dealing with things like who's going to be impacted by the technology, so stakeholders. It's work about ethics, so what are the long-ranging implications of this kind of technology? And the second phase is an empirical phase. So this is sort of like when the technology and human beings interact or bump up against each other. What can we learn from empirical work? And the final phase is the phase where the engineers usually do most of their stuff, is the technological phase. So the idea is you take the conceptual and the empirical information, and then you try and develop a technology that supports those sort of positive outcomes that you've identified. And it's quite an iterative process. So usually what you do is you will make a prototype, and then you will sort of refine it, and you'll maybe do some empirical work to see how did that prototype work? Did it achieve what we had intended? And then maybe a reevaluation of some of the conceptual work will come in connection with that. So it's there's quite a lot of interactions between these phases, quite a lot of iterations that take place. So it's a very holistic methodology of technology development. In my thesis, I looked at 2 different case studies. Briefly, at the beginning, I looked at a case of a humanitarian cargo drone that's being used in Peru to deliver medical samples from a remote village into a main hospital. So that was sort of some desk research to understand VSD and how it worked. And then the bulk of my work was about a humanitarian a public healthcare drone here in Denmark. So you can see most of the research papers. There were 5 research papers in total dealt with this drone that you can see behind me here. And I wanted to give a quick overview of sort of how the different papers fit into the VSD process. So a lot of them actually deal with conceptual work. They don't deal too much with explicitly with a wide range of stakeholders. But what I saw coming from a I would say, traditional engineering background into this sort of like ethically informed technology development work was that there was quite a lot of distance between the ethicists and the engineers. So, for example, in our research group, we have a good collaboration with the humanists, the social scientists in particular. So we kind of work a lot with this empirical phase. We go out and we do experiments, we do surveys and ask people what do they think about this drone and when do they feel comfortable with it, how close can it be, this kind of stuff. But I saw a bigger gap between the technologists and the philosophers. And that's why I kind of focused on this conceptual phase, because I thought there was quite a lot of very interesting stuff that could be mined from that and then applied to drone technology. This is actually a really important slide as far as the work that I did and how I did it. So engineers are typically coming from what's called a positivist worldview. So that means that we think that things are quantitative, or we tend to like to measure things in a quantitative way, and we tend to like to use experiments, and we tend to we prefer to work in a deductive way. So we like to take a general theory and then we like to apply it in specific cases. And in this work, what I did was we actually took a pragmatist worldview, and what that meant was my research question was sort of how do we create drones that benefit society? And then using this pragmatic worldview, we said, okay, what kind of tools and approaches can we use that will help us towards this aim? It could be quantitative, it could be qualitative. Whatever is the right tool for the job, we will use. So this is the first case study. As I mentioned before, it's about this humanitarian cargo drone used in Peru. And this is the first paper that was written. It was a paper that was a collaboration between myself and a colleague in the philosophy department. And the first one was, this was a conference paper. And actually that was a strategic choice because I saw some very complicated, very nice, but very complicated ethics papers. And I wanted to sort of make a short and concise sort of like application of classical value sensitive design into this specific case. And I think maybe it wasn't the drone itself that was so interesting, or the redesigned drone that I proposed that was so interesting. It was more the process, the things that we need to consider when we're designing technology. For example, in this case, it was we might need to think a lot about how we might impact the local workforce. So if a humanitarian organization comes in with a lot of money and a lot of resources, and then they come and replace the boat operators with a bunch of high-tech drones, then there might be some really problematic things that happen with the local workforce. Those people that are working with value-sensitive design will be very familiar with this. It's sort of a list of human values, and this is quite useful for people like engineers that are not so familiar with these concepts. There's a lot of discussion in the ethics community if these are valid, or or if they fit to every circumstance. But I would say it's a good place to start, especially if you come at the work in an abductive way, as I did. So sort of applying theory and then modifying it, applying theory and then modifying the theory. Now we can get into the main body of the work, which was this healthcare drone here for use here in Denmark for public healthcare. Yeah, this one is going to be operated from the islands, excuse me, south of the island that we're on here. So from remote islands into the main hospital. And its main purpose is to carry things like small medical samples, blood samples, and things like this. So the rest of the papers dealt with this. And I would say this is probably one of the main contributions of the thesis. This was a collaboration with Amy van Weinsberg at the Technical University of Delft. So I was there for a few months, and her and I collaborated on this, an ethical framework to develop these kind of drones. And we saw an ethical framework being quite useful because there aren't any in drone design. So if you think about artificial intelligence, for example, there's dozens of ethical frameworks. People love to discuss that topic. And now they're actually trying to summarize them because there's too many. And in drones, we have basically nothing to go on. And we saw that there was an opportunity within the context of healthcare to apply these bioethics principles. So these principles that have been developed over many years in the healthcare industry, and also we saw took some inspiration from AI. So there's some similar characteristics of AI and drones where we saw this good opportunity to apply them in this new context. So this work was quite, I would say, theoretical and published in Ethics Journal. This is something about the construction of that framework. This is based on Dr. Vanderpoel, who's here today. His hierarchy of values hierarchy. I'm pretty interested to hear what he thinks. Hopefully we did it justice, but we can get into that later. So basically what we did was we mapped these more abstract ethical principles, excuse me, down to human values. And then below that level, we will see things like contextual norms. So like what's going on in the certain society where this drone will be implemented. And then that leads us eventually down to the design requirements, which is where the engineers do their work. They try to embody these different human values into the technology. One piece of feedback that I got on the thesis was something about the number of design decisions. Actually, there's a very high number of design decisions that go into this process. So normally as an engineer, you're kind of weighing and balancing a bunch of different criteria. So you might think about the payload and the range and the battery and the safety aspects. And now you add in a bunch of what some of us might see as extra things like things about privacy and things about human welfare and jobs and fairness and all this kind of stuff. So the number of design decisions that you need to consider goes up quite dramatically. And so that's another thing that I'd be interested to discuss with the committee on later is sort of how do we manage this overwhelming, sometimes overwhelming number of design requirements. I think Ivo called it moral overload, and I definitely experienced it as an engineer trying to incorporate all this stuff into what's in the end kind of a fancy remote control airplane, let's be honest. The third paper, let's see, what was this one about? Oh yeah, this one was about just applying this ethical framework. So again, we developed it in sort of an abductive way. We came up with a framework and then we applied it. And as we applied it, these two papers were actually written in parallel. As we applied it, then we checked, does the framework make sense and vice versa. So this work included analyzing an off-the-shelf drone and then sort of trying to develop a new, better drone compared to the baseline. And based on this sort of like early conceptual work, then the drone itself started to take shape. So I was able to make some design decisions like the basic layout should be fixed wing, should be around a kilo, plus or minus, should have the propeller in the back. We can already start to see some of the stuff about the explicability of the technology. So making it easier to understand who's operating it. So this has the paint scheme of an ambulance here in Denmark. And then some other explicability enhancing features, which includes this proposed smartphone app. So if a drone is flying near you, you will have some kind of a notification of who is responsible for it and what is it that it's doing. So yeah, I actually experienced there was a drone flying past my window the other day in the city, and it was a little bit unnerving. I could tell, I think I know what kind of drone it was. I think it was just a mapping drone, but that's only because I'm a drone nerd. I think if I had been a normal person, I might have been even more paranoid about it. So yeah, explicability is a big one in drone technology. The fourth paper was focused on the principle of non-maleficence. So that's don't do bad stuff. And in this one, I wanted to sort of dive in just to the risks of drones. And again, this was a conference paper. I wanted to make it quite concise, and I wanted to give some inputs from philosophy of technology and sort of some of the risks that we're already seeing of drones, and in a concise way say, what are some of the things that we need to consider as drone engineers so that the technology doesn't go wrong. And one of the key elements that I found was that setting limits to the capabilities of the drone could be a quite useful approach to limiting the risks. So in engineering, we tend to approach things from a maximization standpoint. So we want the drone to do as much as possible, fly as far and fast and carry as much and all this. So coming at it from a different perspective is I think, a little bit unique and quite interesting for us, because if you say, okay, maybe we should limit the payload so it can just carry certain things. Maybe we should limit the capabilities of the camera system so that it can't interfere with people's privacy, this kind of stuff. So I think that one I was actually quite nervous because that was submitted to a drone conference, and the reviewers were very happy with it. So that was good to hear. They were also concerned about some of the risks. Yeah, and another aspect of this is that we developed a number of design principles. So sort of like design prompts or questions, things to consider. So context of use is quite critical here. Oftentimes with drones, you will develop a drone in one context and then it will get used in another context. So this is something you need to consider. And then of course, things like privacy, jobs, and the potential for misuse. And the fifth one, probably maybe the most interesting, but the most abstract, thinking about the future implications of the technology. So what are we headed with the stuff that we're building right now? Are we just automating everything, or are we automating to make meaningful human work, for example? The fifth paper was some empirical work, and this was focused in on this concept of explicability in drones. So we know that understanding what the drone is doing and who's behind it is quite challenging. So this was some early indications of what people thought as far as what the visual and sound profiles of the drones were, and if they connected them with healthcare, for example. And again, this was used to sort of to attempt to generalize how does one design for explicability in drones. And so that ended up in these design prompts that will hopefully be useful tools for engineers that want to design for explicability. Now into the technology part. Finally, the stuff I'm more comfortable with. So all of this work, all of this ethics talk, in the end, it's because we want to develop an actual thing. We want to build something in physicality. And when I started this work, at first it was really difficult for me to wrap my head around, but I knew that I wanted to be able, when I was done, to point at what was different about this drone compared to other drones that hadn't been developed with this process. And here I've attempted to do so. So for example, you can see the drone has the propeller in the back, which is kind of uncommon for a fixed-wing drone. So that increases the safety. It also has a gear drive so that the motor turns at a very slow speed, and the sound profile is much less annoying. It's a lower frequency sound. This goes all the way down to the materials that the body is made of. So we started doing experiments using wood core, trying to reduce the amount of carbon fiber, for example, or especially epoxy. There's some carcinogenic effects that go into the manufacturing of epoxy composites. And then again, yeah, things such as the color and the markings, all this stuff is very important. Yeah, and then in the end, you get a nice prototype like this, you know. And of course, it's not a drone if it doesn't fly. So here is a short video of the first flight. And this is the first drone that's ever been produced based on value-sensitive design, explicitly based on value-sensitive design methodologies. All right, I think you get the idea. It was 2 minutes of me almost crashing, but it does work. Might need to adjust the pitch sensitivity a little bit. Yeah. Here's the final prototype. You can see that it actually has, it's taken advantage of these capability caution principles. Excuse me, so it's actually quite small with a fairly limited payload capacity on purpose. So the aim was just to be able to carry 2 of these medical samples at once. And you can see there's also some safety precautions built into the cargo bay itself. So it's only big enough to accept these samples, and it has an RFID system on it to sort of secure the samples and make sure that other stuff doesn't get placed onto the drone. Yeah, the end of the thesis is we made it as an epilogue. And so another piece of empirical work that we did was I worked with a colleague from the humanities, and we tried to figure out what are my values as an engineer. And this was quite interesting because over these last few years, I would say that my perspective of what my responsibilities are as an engineer has shifted. So at first I kind of felt like if I was making technology was good. And if I was making it, then that was good. So problem solved, sort of like ethics checked, ethics box checked. And now I see that it's much more complicated than that. I feel like I should and am happy to take on more responsibility for the things that I produce and put out into the world and all the impacts that they're going to have. So I think this changes the mindset of how you go to work every day. And it also, it could even be construed as sort of like some type of activist engineering. So to be thinking like, how can we use the skills that we have to make the world a better place, in a proactive kind of way. Yeah, after these couple of years, I have some, excuse me, I have some sort of high level recommendations or reflections on the process. I think we should take more responsibility as engineers. Of course, we could discuss if the engineer is strong and has a lot of influence or not. But I think that we can, of course, take on more responsibility than we need to be demanded of. I also think that in the engineering field, we need to embrace these very holistic kind of practices and interdisciplinary work, because we can't really separate the technology from the ethics, and human society would be, you can't really consider human society anymore without considering the technologies that we're using. So then we need to do engineering in a very holistic way. And I think this conceptualization of drones or any kind of technology being good or being bad or evil, utopian or dystopian, it's kind of good for movies, but it's not really how real life is. So far, I haven't seen an example of a perfect drone, and I don't know that such a thing exists, but there are definitely better ones and worse ones. I also think that we have a lot of opportunities when it comes to educating engineers. So there's some empirical evidence that indicates that engineering students care less about society as they go through their engineering studies, which tells me that we're not doing our job properly. So we need to remind them, that what they do does matter, and that it will have wide-ranging effects on society. So yes, drones are not a neutral platform from an ethical standpoint. And my final reflections on interdisciplinary work, it's very hard. In some ways it would have been, well, I know for a fact it would have been a lot easier to sort of take one part of the drone and dive into it and go to the lab and do experiments and have some very nice straightforward data. But I think I've got a lot out of this sort of like very holistic viewpoint of technology development. I feel much more secure in myself as an engineer and what it is that I'm doing, what it is that I'm putting out there. And if I had to choose between a mediocre engineer that's working in a holistic way and a very good engineer that's working in a very narrow way, I think I would choose the first, because just optimizing in a very small part of the process isn't going to do as much good as this society. This was also writing about interdisciplinary work is extremely challenging, and my thesis grew and shrank in size many times. It went 50 pages bigger and 50 pages smaller, and that's because it was hard to know what to include and what not to include. I mean, and to know who your audience is. So is it engineers? Do they only want to know the technical specs? Is it just philosophers? Do they just want to hear about the philosophy? So I think this is something it would be interesting to discuss with the committee is, where do we draw the line, or what do we include and what don't we include in this kind of work going forward? This was, as I said, very interdisciplinary work. And if I had to list everybody that helped me, it would be pages and pages. These are just the people that directly worked on the stuff that's in the thesis. And finally, I just want to say thanks to the Danish taxpayers because they funded this research. And I hope that they feel like they got a lot for their money. Thank you.
Excellent. Thanks, Dan.